Assalamualaikum warahmatullahi wabarakatuh. Thanks for the opportunity that has been given for us from Group 3 to present about mortar and concrete. Now I will introduce the group member. Start from Jacqueline Caroline with studying identity F11123137, and then Putu Julia Bezalel F11123056, Muhammad Errol Razabani F11123062, Muhammad Fadil Marifat F11123072, Muhammad Farid Achmat Triana Putra F11123050, Alfredo Michael Nante F11123104, Arya Ramasatria F11123144, and the last one is Gilbert Johannes Steve Mainti F11123003. We will explain start from the meaning of mortar and concrete.
So I'm gonna explain about the definition of mortar and concrete. For the first is mortar. Mortar is a workable paste used to bind construction materials such as bricks, stones, or blocks. It is primarily used as a bonding agent between these materials. For the second one is concrete. Concrete is a strong and durable building material used for construction, particularly for structural purpose. For the next is function of mortar. Binding materials. Mortar holds together masonry units such as bricks, stone, or blocks. It helps in creating a solid, unified structure by filling the gaps between the units. Mortar acts as a cushion between masonry units, distributing the load evenly and preventing direct contact between rigid materials like bricks or stones. This helps to avoid cracks due to differential stresses. For the third is sealing joints. Mortar fills the spaces between units, creating a watertight shell that prevents the ingress of water, air, and other environmental elements, thus protecting.
I'm gonna explain a mortar. Mortar is mixture of construction material consisting of cement, water, sand, and sometimes additive. It serves as a binding material in construction, primarily to join building elements such as bricks, concrete blocks, or natural stones. Here are the main functions of mortar in construction. 1. Binding building elements. Mortar is used to bind materials like bricks, natural stone, and concrete blocks, forming a solid and stable structure. Second, load distribution. Mortar helps distribute the load among the building elements evenly, reducing excessive pressure on any single point and preventing cracks in the bricks or other materials. Third, vibration damping. Mortar has properties that can absorb vibrations, increasing the stability and the strength of the building, especially in structures exposed to shocks or temperature change. Fourth, weather protection. Mortar helps prevent the infiltration of water, wind, and moisture into the building structure. This is crucial for preventing damage to building materials caused by corrosion of weathering. And the last, as an aesthetic function. In addition to its structural role, mortar also provides an aesthetic appearance to buildings, buildings by offering a smooth and neat surface between the joint elements. The quality of mortar depends on the composition of its ingredients and the method of application, which affects the strength and durability of the building.
Types of mortar and their uses. There are two types of mortar. The first type is type N mortar. The composition is medium strength with a mixed ratio of 1 part cement, 1 part lime, and 6 parts sand. The strength is 750 pounds per square inch. The usage is the most common type of mortar and is used for general purpose masonry work. It's suitable for above ground exterior and interior load bearing walls made of bricks, stone, or blocks. It balances strength and flexibility, making it resistant to weathering. The application is exterior walls, chimneys, and soft stone masonry. And the type O mortar. The composition is low in strength with a mixed ratio of 1 part cement, 2 parts lime, and 9 parts sand. The strength is 350 pounds per square inch. The type of mortar is a weaker mortar and is used primarily for interior non-load bearing walls or for the repair of old masonry structure where a softer mortar is required. The application of type of mortar is interior walls, restoration of historic structures, or repointing old brickwork.
And next, I'm gonna explain you about how to make mortar. For the first is the ingredients. Cement. Portland cement is commonly used. Sand. Use fine, clean sand. Water. Clean water is essential. Ratio. A common mix ratio is 1 part cement, 3 parts sand, and enough water to achieve a workable consistency. Steps. For the first is measure. Use a measuring container for accurate ratios. Mix dry ingredients in a mixing container or wheelbarrow. Combine the cement and sand thoroughly. Add water. Gradually add water while mixing until you reach a smooth, workable consistency. Avoid adding too much water. Test consistency. The mortar should hold its shape but be workable enough. About mortar, the next is I'm gonna explain you about concrete. Types of concrete and their uses. Normal strength concrete or NSC. Composition made with standard ingredients, cement, water, and aggregates. Properties average compressive strength around 20 to 50 MPa megapascal. Uses suitable for pavements, residential buildings, and non-structural components. For the next is high strength concrete. HSC composition uses low water cement ratios and higher cement content. Properties compressive strength exceeds 50 MPa. Uses used in high rise buildings, bridges, and structures requiring high strength. And next is high performance concrete, HPC. Composition contains chemical and mineral admixtures to enhance performance. Properties improved durability, workability, and strength. Use used in complex and challenging construction environments such as long span bridges and offshore structures. For the next is lightweight concrete composition. Includes lightweight and aggregates like pumice, expanded clay, or perlite. Properties lower density and reduced dead load and on structures. Use used for building blocks, insulation, and load-bearing walls in low-weight structures. For the next is reinforced concrete (RC). Composition concrete combined with steel reinforcements. Properties enhance tensile strength due to steel reinforcements. Uses common in beams, slabs, columns, and foundation for both buildings and infrastructure. For the next is pre-stressed concrete. Composition reinforced with high tension steel strands before concrete is cast. Properties excellent in handling tensile stresses, minimizes cracking. Uses used in long span bridge, precast griders, and heavy load bearing structures. Self-compacting concrete (SCC) composition high flowability without the need for mechanical vibration. Properties fills formwork easily, reduce labor, and improves surfaces finish. Uses suitable for structures with congested reinforcements and complex formwork. Air entrained concrete composition contains microscopic air bubbles. Properties increase resistance to freestyle cycles and durability in cold environments. Uses used in pavements, runways, and structures exposed to severe weather. Fiber reinforced concrete or FRC composition concrete mixed with fiber steel glass synthetic. Properties improve toughness, crack resistance, and impact strength. Uses used in industrial floors, pavements, and tunnel linings. Polymer concrete composition blinders made from polymers instead of cement. Properties high chemical resistance and fast setting properties. Uses ideal for repairing all concrete, chemical resistant structures, and specialized. I'm gonna ask you all to make concrete. Materials needed. Cement, usually Portland cement with AC as the blinding agent. Sand, fine aggregate that helps to fill voids between the coarse aggregate and provides smoothness. Gravel or crushed stone, coarse aggregate for strength. Water, entities the chemical reaction hydration to bind the materials. Optional additive, add mixtures for improving specific properties like workability, durability, or strength. The next is the tools of make concrete. A mixing container, wheelbarrow, bucket or concrete mixer, shovel or hoe for hand mixing, measuring bucket, trowel for finishing. Standard mix ratio. A common mix ratio for general purpose concrete is 1:4, which means 1 part cement, 2 part sand, and 4 part gravel or crushed stone. Water, enough to achieve the desired consistency, typically around 0.5 to 0.6 times the weight of the cement. The mix ratio can vary depending on the application. For example, foundation work 1:3:6 weaker concrete, driveways, patios 1:2:3 stronger concrete. Summary of steps. Measure ingredients cement, sand, and gravel. Sorry. Mix dry ingredients thoroughly, gradually add water and mix to desired consistency. Pour to concrete and compact it. Smooth and finish the surface. Characteristics of good concrete. Compressive strength. Definition: compressive strength refers to the ability of concrete to withstand loads without being crushed. It is measured in megapascals or pounds per square inch after curing for 28 days. Importance: high compressive strength is critical for supporting structural loads in building bridges and other infrastructure. Good quality concrete typically has compressive strength ranging from 20 megapascal to 50 megapascal, depending on the specific application. Durability definition: durability refers to concrete abilities to resist environmental factors such as weathering, chemical attacks, abrasion, and freestyle cycles over time. Importance Importance: a durable concrete structure can last longer, reducing the need for repairs and maintenance. This characteristic is especially crucial in environments with aggressive conditions. Definition: workability is the ease with which concrete can be mixed, placed, compacted, and finished without segregating or bleeding. Importance. Good workability ensures proper placement and compaction, which directly affects the strength and durability of the concrete. It can be controlled by adjusting the water-cement ratio using admixtures or selecting appropriate aggregates. Low water cement ratio. Definition. The water cement or weight per se ratio is the ratio of the weight of water to the weight of cement in a concrete mix. A lower ratio needs to higher strength and durability. Importance. A typical water-cement ratio for good concrete is between 0.40 and 0.60. A lower water-cement ratio reduces porosity and increases strength, but too low of a ratio can affect workability. Resistance to chemical attack. Definition. Concrete should be able to resist chemical attacks from sulfates, acids, chlorides, and other aggressive substances that can cause deterioration. Importance. In environments exposed to aggressive chemicals, it is essential for concrete to maintain its integrity over time. This can be enhanced by using appropriate additive and cement types. Proper curing. Definition. Curing is the process of maintaining adequate moisture, temperature and time to allow the concrete to reach its maximum strength and durability. Importance. Proper curing prevents the concrete from drying out too quickly, which can cause cracking and reduce strength. The standard curing time is 28 days, during which the concrete gains most of its final strength. Low permeability. Definition. Permeability refers to the ability of concrete to allow fluids or gases to pass through its pores. Importance. Low permeability is essential for protecting concrete against water penetration and chemical ingress, which can lead to corrosion of embedded steel reformers and degradation over time. Cohesive. Definition. Cohesiveness refers to the ability of the concrete mixture to stick together without segregating. Importance. Good cohesiveness prevents issues like honeycombing and ensures a uniform distribution of aggregates, which contributes to the concrete's overall strength and appearance. Minimal shrinkage and creep. Definition. Shrinkage is the reduction in volume as concrete dries and hardens, while creep refers to the gradual deformation of concrete under sustained load over time. Importance. Minimizing shrinkage and creep is crucial for preventing cracks and deformation in concrete structures, especially in high-load applications like bridges or high-rise buildings. Freeze-thaw resistance. Definition. Freeze-thaw resistance is the ability of concrete to withstand cycles of freezing and thawing without significant damage. Importance. This characteristic is essential for structures in cold climates where water can freeze within the concrete, expand and cause cracking or scaling. The use of air and terraining against can improve the freeze-thaw resistance.
That's all the material about mortar and concrete that we can provide. If there are any wrong words, please forgive. Thank you.